Welcome to my channel. In this video I will show you the global version, the original, brand new top 5 best-selling vertical wind turbine generator in 2025 product on Aliexpress, with discount price. Check discount price and buy from description below link. Are vertical turbines the future of offshore wind power? Forbes A concept rendering of offshore vertical axis wind turbines, VOTs. World Economic Forum. What makes renewable energy so exciting is the immense economic potential of groundbreaking technology advancements. A recent discovery by engineers of Oxford Brookes University's School of Engineering, Computing, and Mathematics could change the design of offshore wind farms forever. The study, led by Professor Iakovos Tsanakis, demonstrates that deep-sea and coastal wind turbines could achieve a 15% increase in power output if traditional horizontal axis wind turbines HOTs are replaced by a vertical axis wind turbine VOT design. While classic hot windmills produce energy with a standard 3-blade pinwheel design, VOT utilizes a more cylindrical shape, with blades rotating around a central shaft. Animated comparison of hot versus leading VOT designs. World Economic Forum. The main issue with conventional hot wind farms, which can number 60 to 70 turbines over 1,500 acres, is that efficiency degrades rapidly in the back rows, due to turbulence from the first rows of the formation. Vertical axis turbines solve this issue by generating less turbulence and, in some cases, even improving the efficiency of nearby turbines. The basis of their research is in computational flow analysis, using 11,500 hours of computer simulations to optimize placement. They also analyze the effects of downstream generated turbulence, which reduces the back row efficiency of traditional HOTs to 25 to 30%. This finding demands further study of condensed wind farms, since the current turbine designs are meant to be used in a singular application. When installed in close proximity to one another, the performance characteristics change with the Department of Energy and universities around the nation. After conducting Phase 1 research under a grant of $4.1 million over 5 years, this solution provided insights which included a reduction in levelized cost of energy, LCOE, through the application of a VOT design. Much of Sandia Lab's initial work was in creating simulations of offshore wind projects. Further developments have included improving the design of airfoils and mechanical generators, as well as perfecting the methods to secure a turbine for safe operation in deep water conditions. The project research concluded in 2014 and was followed by a Department of Energy publication in 2017, establishing the official design recommendations. Current VOT market solutions are all geared towards microgrid and extreme weather applications. They possess an inherent benefit in that they are able to perform well in stressful weather environments. Turbines are able to function even in typhoon weather, which can be a lifesaver for deep ocean water infrastructure, such as oil wells. Nations including the United Kingdom and Germany are already at the forefront for production capacity and investment in offshore wind. The British Isles are home to the first GE-made 12 MW megawatt offshore unit, the same design being used in the Vineyard Wind project. British interests reside in coastal sea applications, where conditions are easily managed by the HOT design offered by GE. The U.S. project is the Block Island Wind Farm 3 miles off the coast of Rhode Island, which produces 30 MW from a series of units provided by GE, enough to power 27,000 homes. Few nations currently use deep-sea wind energy, as it can cost twice as much as the coastal alternative on an LCOE basis. Offshore wind has found a niche application for providing offshore power. One of the most demanding clients for offshore energy is the oil industry, which currently powers platforms with diesel-electric generators. The typical offshore oil well consumes 20 to 30 cubic meters, 5,200 to 8,000 gallons, per day. This specific application allows a high LCOE like offshore wind to be considered competitive. Recent investments by Norwegian energy provider Equinor in the North Sea focus on powering their oil platforms with offshore wind. The proposed Hywind Tampen project includes 11 floating HOTs producing 88 MW, meeting upwards of 35% of energy demand for a series of 5 offshore platforms. The Hywind project is expected to cut 200,000 tons of CO2 emissions per year. Further investment in offshore wind technology could eliminate the need for diesel fuel altogether. In the United States, there have been small-scale projects to test the designs of floating HOTs. In 2013, a scale model was installed off the coast of Maine by the Deepwind Consortium, working in partnership with the University of Maine. The Seattle-based Principal Power has installed their patented wind float design off the U.S. West Coast in a deep-sea application. Principal Power currently has 5 units in operation and has proven their design's ability to withstand up to 17 meters, 55.9 waves, and 41 meters per second, 92 miles per hour, winds. These choices may be out of date. All of these products may not be in stores. We don't know when this will be back in stock. You need to go Best Vertical Wind Turbine Generator in 2025 review link to see the most recent updates to the list. Thank you for watching. Please subscribe to this channel.